Hi everyone, nice to meet you. Welcome to the Motion Technical Support. Today, we will learn Motion Controller Laser Galvanometer Control. That is, how to match galvanometer motion with laser switch to move precise trajectory. Firstly, we need to prepare one controller with galvanometer axis, one laser galvanometer device, which contains two galvanometer axes and a laser generator. Then PC, cables, DC and Zs, and our old friend, Z develop to program. Here, we use ZMC420 scan controller. Its wiring is important. Please refer to this picture. These two blue terminals are galvanometer axis channels. Each one has two galvanometer axis interfaces, which control X and Y separately. Other terminals are the same as ordinary controllers. There are all four parts: main power, connect positive 24 voltage terminal to 24 voltage DC power positive pole, and connect EGND terminal to 24 voltage DC power negative pole. Wiring between controller and PC, just use one cable to connect corresponding Ethernet. Then, wiring between laser galvanometer head and controller. Connect two galvanometer axis to controller galvanometer axis interface. Here, use axis 4. At this time, scan axis are axis 4 and axis 5. Each interface of laser generator also should be connected. Actually, use these outputs to control laser switching on and off through generator. The last, if needs actions, connect to control axis according to servo type. Please pay attention, the output port supports PWM can achieve laser output. Now that ZMC420 scan is used, let's know more about it. It is a bus controller. It supports pulse axis and ACAT or TAX axis. There are up to 20 axis motion control to achieve many functions, such as linear interpolation, any circular interpolation, space arc, helical interpolation, electronic cam, electronic gear, synchronous follow, virtual axis, etc. Please look at this ZMC420 scan. There are only 3 pulse axes, but actually it supports 10 pulse axes. The remain are in out. Later we will learn how to configure out as pulse. Except motion control, of course it is with laser galvanometer control. Laser galvanometer is specified for laser processing. It can be seen there are one laser generator and two galvanometer lanes. Actually, X and Y are controlled by two motors. Laser is reflected. XY platform motion is formed. When the angle of laser sent by laser generator is changed, the angle reflected also will be changed. Then, the workpiece position can be controlled according to needs. And in actual application, connect X to galvanometer axis interface of controller. What's more, laser galvanometer has some advantages. It is with very small inertia and low load. The system response can be extremely rapid because it only needs to drive reflective lens. We talked about laser galvanometer briefly, then see the whole galvanometer control process. Please look at the right picture. Use Ethernet to connect PC and ZMC420 scan. Then, controller controls laser head through galvanometer axis interface. This is the used protocol. At last, it controls the workpiece position made by scan head. This part controls the workpiece motion. For development method, there are two ways: the motion Z develop programming software, or host computer. These are supported. As mentioned before, it needs out that supports PWM function. Please refer to this form. Out 0 to 11 all support PWM, but only when out is on, PWM can output really. And in laser galvanometer control process, control is realized through motion commands. For example, PWM duty sets duty cycle. PWM frag sets frequency. This picture shows these two commands. Duty cycle means in one period, the occupation of high level and low level. If the duty cycle is 0.5, which means half time for high level, half time for low level. If 0.6, high level time occupies 60% in one period, and PWM outputs high level firstly by default. For the frequency, actually it is the period. The frequency is bigger, PWM level changing is faster. When these two are set, use move up command to operate laser output. Then, let's see how to use these commands in details. Number 1. Duty cycle instruction. It is used to control the laser energy output. If you need to close PWM, set it to 0, and the PWM frequency must be set well or modified well before switching on PWM. There are only two parameters, the null and the duty cycle. If the field number doesn't support PWM, it won't work. Number 2. Frequency. The same as duty cycle, two parameters, and number must support PWM. Attention, the frequency has the limit. Let's see one example. Set frequency, then set duty cycle. The order can't be wrong. Here, set 2000 Hz for out 2. The corresponding period is 0.5 ms. The duty cycle is 0.5 for out 11. The number is relative to actual wiring axis. Number 3. PWM in buffer. It only outputs PWM when in buffer. There are three parameters. Only one command can set duty cycle and frequency, and this command is better to use when duty cycle and frequency need changing with the motion. This shows one move PWM example. From here, save them into buffer. Here, close PWM, move 10 units, then open PWM. Up 0, duty cycle is 0.111, frequency is 2000 Hz. Delay 100 ms. Modify duty cycle and frequency. They become 0.555 and 3000 Hz. Move 20 units. The last, close PWM. If former two are used in program, please note the last set takes effect in motion. That is, behind duty cycle and frequency will cover former setting. Because these three move commands don't finish, they need to be got from the buffer then to be executed. But the program scanning is very quick. Then the program considers the last configuration is right. See you next part.